It already took too much time. Almost more than 30 minutes. Okay, so stop sharing your screen, Rizquddin, and we switch to the next presenter from Urgench State University. And Shakhnoza Khudayberganova is from Urgench State University, and her topic is improving the technology for protein extraction from wheat produced in cheese manufacturing. Okay, please, Shakhnoza, share your screen and go ahead. Oh yeah. Yeah, please. Yeah. Good.
Good afternoon, everyone. My name is Shakhnoza Khudayberganova from Urgench State University. Today I will present my research on improving protein extraction from cheese whey. Our goal is to transform a common dairy byproducts into a high-value resource using advanced membrane technologies. Our presentation is structured into three main sections to provide a comprehensive view of the technology. First, we discuss the rationale for recovering proteins and the specific composition of whey, focusing on beta-lactoglobulin and alpha-lactalbumin. Second, we detail the technical integration of ultrafiltration and defiltration systems. Finally, we analyze the optimization of processes, parameters, and the resulting economic and ecological benefits. This flow will demonstrate how we move from raw byproduct to a high-value, sustainable protein concentrate. To understand the scale of this research, we must look at the industrial reality. Producing just 1 kilo of cheese generates 9 kilo of whey. This massive byproduct represents a severe ecological risk. Its high biological oxygen demand levels can cause significant water pollution if not treated properly. However, whey isn't waste. It contains 20% of the original milk protein. By shifting our perspective to see whey as a high-value raw material, we can recover essential proteins like beta-lactoglobulin and alpha-lactalbumin, turning an environmental liability into a profitable economic asset. The core goal of this study is to improve protein extraction using advanced membrane technology. We aim to optimize the process to maximize protein yield while strictly preventing denaturation, ensuring the proteins stay in their bioactive state. Our research focuses on three pillars: enhancing the purity of the final product, maintaining high solubility for food applications, and increasing the overall energy efficiency of the dairy plant. We want to show that high-quality protein production can be both technically superior and commercially viable. Whey is a complex raw material appearing as a sweet whey, pH 5.6 and 7, or acid whey, pH 5.1. Its dry matter is predominantly lactose, 75%, and minerals, which our technology effectively removes. The nutritional profile is led by beta-lactoglobulin 50% and alpha-lactalbumin 20%, alongside minor bioactivities like lactoferrin. These proteins are rich in a branched chain amino acids such as leucine and valine. Because of their high digestibility and biological value, isolating these fractions is the key to creating premium nutritional products. Our improved production technology follows 5 systematic stages. It begins with clarification to remove fat and cheese fines, followed by low-heat pasteurization to eliminate microbes while protecting protein structure. The heart of the process is ultrafiltration, which concentrates the protein using semi-permeable membranes. We then apply diafiltration, which acts as a washing step to remove residual lactose and salts. Finally, spray drying dehydrates the concentrate into a stable, high-quality protein powder ready for the market. Optimization is where we achieve our greatest gains. By calibrating the transmembrane pressure, we improved membrane flux efficiency by 15 and 18%, maintaining a precious pH range of 6.2 and 6.5 was essential to prevent protein aggregation and ensure stable separation. Additionally, by keeping processing temperatures below 55 degrees, we successfully preserved the native state and biological activity of the proteins. These controlled parameters are the foundation for the 20% increase in total protein recovery that we observed in our results. The results of our optimization are significant. Not only did we increase recovery by 20%, but the final product reached a protein concentration of 80 and 85%, meeting international whey protein concentrate 80 standards. This opens new revenue streams as high purity whey protein concentrate 10 and 15 kilogram. Beyond profit, we achieve a 90% reduction in biological oxygen demand levels, drastically lowering the environmental footprint of dairy plants. This transition from waste management to value creation is the essence of modern sustainable dairy engineering. As this diagram illustrates, we are implementing a circular economy model. Traditionally, whey was a pollutant that left the system as waste. By using our optimized membrane technology, we close the loop. We extract high-value proteins from the raw whey and return clear water and minerals back to the system. This not only protects our water ecosystems by reducing pollution by 90%, but also transforms a disposal problem into a profitable, renewable resource for the entire industry. In conclusion, our research proves that optimized ultrafiltration and diafiltration technology increases protein yield by 20% while preserving the activity. This approach ensures sustainability by reducing biological oxygen demand loss by 90%, effectively transforming industrial waste into high-value whey protein concentrate 80 and 90. Adopting this circular economy model is the key to ensuring both economic profitability and ecological safety for the future of the dairy industry. I used these references, and thank you for attention.
Thank you, Shahnoza. And the official opponent is Dilafruz Kadamova from the same university. And please, Dilafruz, your comments, questions?
Okay. Your presentation was very good, Shahnoza. First of all, I really liked your presentation. You are well organized. How to introduce yourself and you said ecological sustainability also. Of course, in some factories, waste is treated as waste and is discharged into sewage systems or even dumped into open areas, which creates unpleasant smell. I think this idea, I mean, it's a great idea that you are trying to eat as a secondary production. However, I have one question. I think is it too expensive? It wouldn't be too expensive because whey contains a relatively too low amount of protein. What do you think about this from a cost perspective? What do you think?
Shahnoza?
Thank you for your question. Yes, you are right. Whey contains a relatively low amount of protein, and the extraction process can be expensive. However, the key point is that whey is usually a waste product, so the raw material cost is very low or even free. In large scale production, modern technologies like membrane filtration make it possible to concentrate the protein efficiently, and also whey protein has a high market value, especially in the nutrition and fitness industry. Also the initial investment can be high. It can be economically viable in the long term if production is well organized and done at large scale. That's all.
Oh, okay, thank you. Other questions? Okay, yeah, go ahead. Dilafruz, would you like to say more? No? Okay. Then, other questions or comments from other students?
Thank you, Professor, for commenting. Thank you for your feedback. I really appreciate your suggestion about reducing the amount of text, and I will consider it for future presentations. Regarding a question, when the process separates the product more efficiently than in conventional methods, the remaining lactose doesn't go to waste. It can be further utilized in several ways. For example, it can be processed into lactose powder, used in the food industry, or applied in pharmaceutical production. In addition, it can also be converted into value-added products and such as lactic acid or biatanol through fermentation. So instead of being a byproduct with low value, the remaining lactose can be reused and integrated into other production processes, which increases overall efficiency.
There and so on. So it's just a curiosity question. I'm very interested in your technology, and I think it's a very great step forward.
Okay. Then maybe...
Thank you, teacher. Thank you, Professor.
Yeah, you may say just thank you. Yeah. Just keep in mind. Okay, anyways, thank you, Shahnoza. It was great. And also Dilafruz and Björn. Maybe we switch to other presenter, Björn, then. So third one is also from Samarkand branch of Tashkent State University of Economics. Alan Birganov ve Gulmira